an introduction to hypothesis testing. So here's basically what's going to happen is that hypothesis testing is often compared to jury by trial, and so you're going to have to suspend your belief right now and you're going to assume that the Food Commission can charge Tony the Tiger with falsely stating the amount of cereal in Frosted Flakes boxes, and that he could go to a trial by a jury for a criminal trial for this. So here's the breaking news. The Food Commission has charged Tony the Tiger with falsely stating the amount of cereal in Frosted Flakes boxes. Tony says that no, actually the machines really put an average of 13 ounces in each cereal box of Frosted Flakes. He says, I'm innocent. And so here's what's going to happen is, you know, Tony must be formally charged with a crime before a criminal court before he can, before anything happens. He must be, before he has trial by a jury, he must be formally charged with a crime. And this is similar to a hypothesis testing. Before you do anything in hypothesis testing, you need to make a claim. So here's our claim. Our claim is that the null hypothesis is that, this is not our claim. The null hypothesis is that nothing is going on. And in other words, that Tony is innocent, that he's really putting 13 ounces of cereal in his Frosted Flakes boxes. And I want you to notice that for the null hypothesis, that it always has the condition of equality. So equal to, less than or equal to, greater than or equal to. That's for the null hypothesis. Well, the alternative hypothesis in your book is HA, and in another book is H1. The alternative hypothesis is our claim. Tony is not putting 13 ounces of cereal in his Frosted Flakes boxes. So this is the alternative hypothesis, and notice the alternative hypothesis is always, it's true if the null is false, it's the opposite of the null, and it's always inequality, it's always not equal to, it's different than, less than, greater than. So you're thinking something's increased, something's decreased. In this case, Tony's not putting, and we're saying not putting 13 ounces because we're going to be mad if he is putting too little or too much. So if it's too little, well, consumers are getting ripped off. And if it's too much, well, maybe our kids are having way too much sugar. So, so again, that's our claim, is that alternative hypothesis, HA. And Tony, same thing in a hypothesis test, innocent until proven guilty. In other words, we are going to presume that the null hypothesis is true. Assume Tony really is putting 13 ounces of Frosted Flakes in his cereal boxes. And again, same with trial by jury. Start with presumption that the defendant is innocent until proven guilty. So let's assume that Tony's putting 13 ounces in his cereal boxes. And this is, you know, a little bit silly, but, you know, advice for the jury, and that you are only listening to what's happening in court. You're not looking at other data or newspaper stories and media, etc. In the hypothesis test, you're basing your conclusion only on data from this one experiment, from this study. You're not looking at other studies. So again, assume the null is true. You take some evidence, right? What's the evidence? Well, in a case of hypothesis testing, we say, let's see if there's really 13 ounces, an average of 13 ounces in these boxes. So you take a random sample of 30 boxes, you weigh the contents, and then if we come up with a sample mean, so all those 30 boxes, weigh them, write the number down, add them all up, divide by 30, and if the sample mean, X bar, or as in your book, Y bar, is 6 ounces, well, pretty much everyone's going to think, yeah, you know what, Tony, you're guilty. You're not putting 13 ounces in your boxes, an average of 13 ounces. So if you come up with 6, you don't really need hypothesis testing. The null is false. You say you reject the null hypothesis and that he's not likely, it's extremely unlikely that the true average of these boxes is 13 ounces. But where's the cutoff? In other words, what if the sample mean was 12.58 ounces? Can we determine the null hypothesis is false and convict Tony of lying? Would we reject the null and say, look, he's not putting 13 ounces in? Well, in my class last Thursday, I did a little poll, and of about I don't know, 50 or 60 students, so about 75% said if it were 12.58 ounces, let him go free. If the sample mean for 30 boxes was 12.58 ounces, let him go free. About a quarter of the class raised their hand and said, no, reject the null, Tony's guilty, and he's not putting 13 ounces in his boxes. So the question is, like, what range would we accept? You know, is 12.5, 12.6, 12.7? What if it was 12? What range would we accept? Well, that's where we come to sort of our probability and our normal distribution of means, our sampling distribution of means. So I'm going to skip forward for a moment and say, well, basically, if we were to say, well, you know, with a sample of 30, the mean is normally distributed, and then we would need some sort of cutoff. And in the past, we've been doing sort of a 95%. If the middle 95%, the 5% and 5% or less, probability of 5% or less is unusual. It's kind of the same thing here. I mean, we're basically doing, here's the middle 95%, we're doing it. If it's a 95% confidence level, then we have alpha is 5%, our alpha level or our confidence level is, significance level is 5%. And we'd say, well, if the test statistic, if basically our z-value is more than 2 standard deviations above or below the mean, this is unusual, and that's evidence to say that it's so unusual, well, reject the null. That's sort of the idea. So let's go back and come to where our significance level, or again, in our book, it's the alpha level, same thing. And then how do you pick the alpha level? Well, it depends. They say, well, in scientific research, the alpha level is often 1%, or you see a 99% confidence level. For consumer and product research, it's often 5%. And for political polling, it's often 10%. And these alpha levels are based on how important it is to really make sure there is a difference. All right, for political polling, it's not going to kill us if we don't know exactly how many votes are for Jeb Bush at this point. However, for scientific research, if we're testing a cholesterol drug, and there are lots of other cholesterol drugs out there, we really want to make sure this cholesterol drug works well before we put it on the market and anybody goes off their current medicine to take this new medicine. So you would have a very low alpha to make sure, like, let's really try and, you know, have a z-value that's farther out there to reject the null. All right, and this is a little cheeky, but yeah, never use a rule of thumb to determine your significance level. In other words, think about your significance level. In real life, you don't want to just say, oh, let's use 5% because everybody else uses 5%. So a lower significance value or a lower alpha level would make Tony's defense attorney happy. In other words, it would be more difficult to reject the null hypothesis at a 1% alpha than a 10% alpha. So we need more information. So given the mean weight of sample cereal boxes is 12.58 ounces and the standard deviation of 2.25 ounces, we can create this sort of confidence level and find what we call a test statistic. In this case, it's a z-score. So a test statistic is a value using the sample data we just got, so in other words, that 12.58 ounces, that mean, and also assuming the null is true. So, and basically, this is for all of hypothesis testing. So if we use proportions, we're going to use z-scores. If we have a mean and we know the standard deviation, we use a z-score. If the standard deviation, population standard deviation is not known, we'll use a t-score. For variance, there's something called chi-square, etc. There's all sorts of test statistics, and we'll see more of those throughout the semester. But this is the idea. Right now, we're looking at z-scores. So we calculate our test statistic, or our z-score, and we have the sample mean minus the assumed this is our null hypothesis. We're assuming there's 13 ounces in the boxes, over the standard error. It's not just over 0.25, it's 0.25 over square root of 30, because again, this is the distribution of means, sampling distribution of means. So if you know the population standard deviation, then you're going to use the z-score. Negative 9.2. Let me just remind you, 75% of my class said, let Tony go free. But knowing a little bit of statistics, when you get 9.2 standard deviations below the mean, you think, that's unusual. And in other words, if you look at our z-score, our critical values for 5% alpha level, it's about plus or minus 1.96. The probability of getting a value of 12.58, a mean of 12.58 or less, is 0.0000000004. In other words, super improbable. It's way out there in that 5% region. And this probability is called is a p-value. So the probability of getting a value of a sample test statistic, in this case x bar, or if you want to say y bar, it's the mean, the sample mean. The probability of getting that sample mean that's at least as extreme as the one found in the sample, assuming the null is true, this is the p-value. So when I say use technology to find the p-value, I will show you in another video how to use StatCrunch to perform hypothesis tests. And we can in fact use the Tony the Tiger example as well. So it will tell you the p-value. It's a very small probability of getting a more extreme test statistic. This is a z statistic than the one we did, assuming the null is true. It's less than significance level. Reject the null hypothesis. Based on the p-value, reject the null hypothesis. We conclude that our hypothesis test that Tony is guilty. The machine does not, in fact, put a mean of 13 ounces of cereal in each box. So in summary, this is what we're doing for a hypothesis test. State the null. Nothing's going on. It's the same, right? So in other words, the mean's really 13 ounces. State your alternative, your claim. It's not 13, it's different, it's changed, it's greater than, it's less than, etc. State your significance level. Where are you going to cut off your values? What's going to be, what's enough evidence? What's beyond a reasonable doubt for in this significance level? All right, calculate your test statistic, your z-score, your another one, other hypothesis test, you'll be calculating your t-statistic or your chi-square test statistic, etc. Find the p-value. That's finding the probability of getting a value as or more extreme than the one you got. Then state your conclusion. If your p-value is less than your significance level, if it's less than a 5% probability or a 10% probability or a 1% probability, reject the null. All right? It's very unlikely that that would happen given the null is true. Reject the null, guilty. If the p-value is greater, in other words, if you had a 20% probability of getting that value, we say that's not that improbable, so you fail to reject the null. You do not accept the null. You fail to reject it. Why is that? Because we do not say Tony is innocent if we fail to show he's guilty. We say guilty or not guilty. You cannot prove his innocence. You can say, we do not have enough evidence to show he is guilty, so you fail to reject the null hypothesis. You fail to show that he's not putting 13 ounces in his boxes. And just like in the court, and just like in similar to hypothesis testing, we can make a mistake. Two mistakes we can make is letting a guilty person go free, acquitting someone who's guilty, or convicting an innocent person. Those are basically the two, there's equivalence in hypothesis testing. So one, convicting an innocent person, that's basically rejecting the null when the null is true. And the probability of rejecting a null when the null is true is alpha, and that is called a type 1 error. If you fail to convict a guilty person, let a guilty person go free, that's fail to reject a false null. All right, and that is a type 2 error, and the probability of a type 2 error is called beta. And we will go over that some more soon. So that concludes our video, and I will do another one soon.